One determinant can be split up into one or two determinants, determinant, delta 2. See, that's the kind of class delta on the mistake. For that you need 1 plus A, 1 plus B, 1 plus C, D, E, F, G, H, I. And this can be written as 1, 1, 1. D, E, F, G, H, I. Plus another determinant which is A, B, C, D, E, F, E, H, I. So you can see here 1 plus A, one complete column. That means if addition sum of 2, some one determinant can be written as the sum of two determinants. In that case, there is column addition will be there. So you can see a column addition 1 plus A. That can be written as 1 and full determinant. Here also A, B, C, another determinant. So that is, if you one column or row also same way. If you instead of this, if 1 plus A, 1 plus B, 1 plus C like this, it can be written as same as row. Then in that case, row will be changing. Here the column will be changing. In that case, the row will be changing. So, only thing is, row will come 1, 1, 1, A, B, and then A, D, G, like that. Okay. So this is one property of the determinants. Let us see another determinant. A, B, C, D, E, F, G, H, I. Let us see another determinant. The determinant is equal to this. And this determinant is equivalent to another determinant. We can write like this. Another determinant, that is A, D, G in the row. Here it is B, E, H in the row. Now, third step we can take like this. C plus C is here, but we can take C plus 2A. And here it is, we can take F plus 2D. And here you can take I plus 2G. This determinant can be tried like this. You can see here. Here A, D, G, B, H, C, F. Now C plus 2 times A. That means R3 changed to, here R3 is changed to R3 plus 2 R1. So you can change, you can write the determinant like that. This property is used in the reduction of determinants. That is, one row we can change into, one row we can change with a scalar, adding a scalar with other row. You can add a scalar, S2 is a scalar. So R3 plus 2 is a scalar added to R1. So you can add like that. Okay. Similarly, you can add columns like that. C1 you can give, you can write as C1 plus C2 plus C3. For R1 you can write as R1 plus R2 plus R3. And also R1 can be written as R2 minus R1. Like that. Like that you can use these formulas for reduction of the determinant. reduction of determinant. We are changing two columns. C2 you can write like C2 minus C1. C2 is C2 minus C1, and C3 is C3 minus C1. Like that you can use these techniques for reducing a determinant. Similarly, R3 can be written as R2 can be written as R2 minus R1, and R3 can be written as R3 minus R1. So you can see here, addition or subtraction you can use formulas. So you can add 1, 2, 3 columns together. Here you can see C1 is added with a 1 here, here also 1, this K or K constant, here is L constant, that is 1. Similarly you can add C1 equal to, in general we can take A, B, C, D, E, F, E, H, I. If delta is equal to this, then we can take an equivalent delta dash, this value equal to A plus LB plus MC, like that, D plus LE plus MF. Similarly, G plus LH plus MI. Here you can write same B, C, E, F, H, I. In general we can write like that. So that means here it is, this column is changed. C1 is changed to, here what is done is C1 is changed to C1 plus LB plus MC, like that. That is C1 is changed to C1 plus C2 plus C3. But here L, here M, constant scalar. So you can see, like this way, you can write the determinant, or you can change the determinant. These columns you can see C1, each element of this C1, each element of C1 is changed to C1 plus LC, 2 plus LC, MC3. So this is one property of the determinant. We already discussed about that. The law of a determinant is, if determinant two rows or columns are interchanged, then the value of the determinant becomes negative. If C1 interchange to C2, C1 is interchanged to C2, C1 changes to C2 and C2 changes to C1, then value of the determinant is negative of minus of delta. Okay, delta dash, value of the determinant delta dash is minus of delta. So like that, columns also same. R1 changes to R2 and R2 changes to R1. Then also the value of the determinant will be equal to delta dash is minus delta. negative of value. Thus we can see if we take 1, if delta is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then delta dash is another determinant we are taking like this. This value we are interchanging C1, that is 3, 6, 9, interchanging C1 and C3. 2, 5, 8 remain same, and here again 2, 5, 8 remain again 1, 4, 7. Its value will be equal to minus of delta, minus of value of this. Let us see an example. Delta, if delta is equal to A, B, C, B, C, A, C, A, B. We will take another delta dash equal to, now for that we will do, as we know, R1 can be write as R1 plus R2 plus R3. Now what we get is here A plus B plus C, A plus B plus C, A plus B plus C. In other rows will be remaining same, B, C, A, C, A, B. Now we can take one row whose first row contains A plus B plus C, so you can take it outside. A plus B plus C into, inside we will get 1, 1, 1, B, C, A, C, A, B. This is our first step. This is our first step. Now we see, these all are 1. Now what we can do is, we can make this 0, we can this 0, these two 1 we can make 0. How we can make 0? We will apply the column change, that is C3, C2 we will change to C2 minus C1, and again C3 we will change it to same C3 minus C1. Instead of C2 we will write here C3 minus C1. So what we get is, the value of the determinant delta dash equal to, then write delta dash is equal to, now first column will remain same, no change, 1BC. Second column will change it to C2 minus C1. So 1 minus 1 is 0 here. Now here it is C minus B. Here it is A minus C. And here also we will see 0, A minus B, B minus C. The right is 3 because here also B, here also C, same B, C. This is the second step. Now we can easily expand this determinant. This because two columns are 0 here, so the value is 1 into, so A plus B plus C into 1 into, now we can write this to elimination, and this C minus B into B minus C minus A minus B into A minus B into A minus C. On expanding, we get a plus b plus c into we can now expand cb minus c squared cb minus c squared minus b squared minus b squared, then plus bc, again minus inside a squared, again here it is ac, but this is minus, so this is plus ac, minus into minus is plus ac. Now again plus ac, then next is minus ba, minus will come plus, so plus ba, minus bc, sorry, minus into minus will be plus, so plus bc and minus bc, so you can get like this. So this will cancel out, minus bc, so we take the minus sign outside. We can write this a squared plus b squared plus c squared minus ac minus ba minus bc. Okay. Here it is 1b c, here it is 0, here it is 0, c minus b, a minus b, a minus c, e minus c into a plus b plus c. So this again equal to a plus b plus c into 1 into, you can eliminate these two and here 1 into you can multiply this minus this. So c minus b into b minus c minus a minus b into a minus c, which is again equal to a plus b plus c into expanding cb minus c squared minus b squared plus bc minus a squared plus ac plus a ba minus bc. BC and BC will cut down and we get like this.